Okay, these are some more problems from section 4.3, and this is number 23. And this is the graph. Now watch out, because we just got through doing some that were just f of x. This is now f prime of x, so this is the derivative. So be careful. We're talking about the derivative now. So this is kind of like what our first derivative line would look like in a way. And the first question, if you look in your book, when is the function increasing? Well, it's increasing whenever the derivative is positive. And it's positive whenever it's above the line. So all you would have to do is cover up the top here, or the bottom. And that's when the derivative is positive. So right above here. So it's going to be positive from negative infinity to negative 2. And it's above the line from 0 to 2. So that's when the function is increasing. And remember, when it's increasing, we use closed intervals at the except for infinity, so it's going to be open to negative infinity to negative 2 closed, and from 0 to 2 closed. Okay, remember, if the derivative is positive on the open interval, then we say it's increasing on the closed interval. All right? And then again, when is it going to be decreasing? Well, it's decreasing when it's below, so it's going to be on the closed interval negative 2, 0, negative 2, 0, and then 2 to infinity. And the infinity is always open. Okay, and they want you to find the local extreme value. So remember, when we look at our derivative test, when the derivative changes signs, that's when we have a relative extrema. So here the derivative is going from positive to negative. So that means my slope is going from positive to negative. So it's going like this, positive to negative. So it looks like I'm going to have a relative maximum at negative 2, 0. I'm sorry, at x equals negative 2, not negative 2, 0. At x equals just negative 2. It looks like I've got a relative maximum because I'm going from positive to negative. Okay? And also, at x equals 2, I'm going from positive to negative. So my slope, you think of it like this, your slope is going from positive to negative, so it looks like this. So something like this, positive slope, even, it looks a little funny because you're looking at the line, but this means a positive slope, this means a negative slope. And this is a positive slope, that's a negative slope. So I've got relative maximums at x equals 2. We don't know what the y values are, we just know what the x values are, excuse me. And then we have a minimum here at x equals 0 because my derivative is going from negative to positive. My slope is going from negative to positive, negative to positive. So like that. So I have a relative minimum at x equals 0. Okay? So that's pretty much how you handle those. Okay, let's take a look at number 24. Same idea. Okay, where is it increasing? And here we'd say, since it's positive on this interval from negative 2 to 2, we would say it's increasing on the interval negative 2 to 2, closed interval. Okay, now you might say, well, what happens with the 0? That's kind of debatable. And I might say from negative 2 to 0 and from 0 to 2. But because they always have that overlap point, and they use a closed interval, like I guess they overlap, so they just basically say it's going to be negative 2 to 0 closed, and closed from 0 to 2 is just going to make it negative 2 to 0. Now it's positive. Now if we're talking about where the derivative is positive on the open interval negative 2 to 0 and then 0 to 2. That would be open interval because it's equal to 0 at these points. But as far as the increasing part, then we would just say it's negative 2 to 2 closed. Okay? And then when is it decreasing? When is the function decreasing? Well, that's when the derivative is negative. So that's going to be negative infinity to negative 2 open. It's negative, which means it's increasing, or it's decreasing from negative infinity to negative 2 closed. Negative infinity to negative 2 closed. And then from 2 to infinity closed because it's below the line. So the derivative is negative, so that means it's decreasing. Okay? And again, the local maximum and local minimum extreme. Okay, here my derivative is changing from negative to positive. Negative to positive. So if I'm going from negative to positive, negative to positive, negative to positive, so I'm going down like this, negative to positive. Or you can think of a V even if you want to think of it like that. And then that means I have a relative minimum at x equals -2, so that's a local minimum at x equals -2. And here it's going from positive to negative, so positive to negative, like an A, or like this, positive, negative, at 2, so I have a maximum. So it's a relative maximum at x equals 2, because my derivative is going from positive to negative. And a local minimum at x equals -2, because my derivative is going from negative to positive. Okay? Okay, so I hope that helps. Remember now we're switching 21 and 22. We were using the graph of the function. Now we're using the graph of the derivative, so kind of watch out. Make sure you're careful to know which you're using, either the function or its derivative. And this is a derivative right here, and here you can see this, I think. That's f prime, f prime. Okay, hope that helps.